So, to find the circumference of a circle, the distance around it, you can either do pi times the diameter or 2 pi r. Those are your two ways to find circumference. How many radii does it take to make a diameter? Do you see why there's 2 r's over here then? So you can use either. It's the same thing, just depending on what you have. Flip your paper to example 2. Number 2 at the top says find the circumference and area, cross off the area, of a circle with a radius of 7, and then I added this sentence, leave your answer in terms of pi. That's kind of like when I say leave in simplest radical form. Okay, so when I say leave in radical form, you keep square roots in your answer. If I say leave in terms of pi, you're actually going to keep pi in the answer. So circumference, we have 2 ways. Use 2 pi times the radius or pi times the diameter. It's your choice. It says the radius is 7. So if I were doing this one, if they give me the radius, I would probably just use the radius formula. 2 pi times 7. Like radicals, you just multiply the digits, the numbers out in front or whatever. So I'm just going to multiply the 2 and the 7. Gives me 14. So our circumference would be 14 pi. And you leave it just like that when it says in terms of pi. If you put it in the calculator, it's going to give you a value about 44, which to me makes more sense if I say the circumference of the circle is 44 inches. That's better to visualize the distance around it instead of saying 14 pi. But a lot of times we just leave them in terms of pi. Go ahead and try the second one, or number 3. Find the circumference, I have to do the area part, of a circle, given the diameter to be 26. Leave this one in terms of pi as well. There's 2 ways, 2 pi times the radius, or pi times the diameter. And when I read this, it says the diameter is 26. So if it were me, I'd use the diameter one. And 26 times pi is just 26 pi. So that's how you would write your answer in terms of pi. If it said round this to the nearest tenth, well then you'd have to get out your calculator and put 26 pi in and then round it to the tenth. Good on those two? Okay, let's apply it here. A circular swimming pool, 16 feet in diameter, is going to be enclosed with a circular fence that's 4 feet from the pool. And I want to know how much fencing material we need to buy. Okay, so my inner circle here, this is our pool. And then 4 feet from the pool, all around it, we're going to build this fence. So if I want to know how much fencing I need, do I want to know the circle's area, the stuff on the inside, or the circle's circumference on the outside? Circumference. I want to know the stuff on the outside. The fence is just going on the outside. So you have 2 ways. 2 pi r or pi times diameter. Find the circumference of the big circle. That's the one that's representing the fence, the big one. The little circle is the pool. You can do it either way. I think the diameter one actually is easier on this one. Diameter is the distance across the circle. So if I want to go all the way across the big circle, 4, 16, and 4 would give me a diameter of what? 24. So then when I come over here to find the circumference, pi times 24. This one says round your answer to the next whole number. Well, when you throw this in the calculator, you get about 75.4. Why would it tell me to round it to the next whole number? I want extra just in case. You can't buy 0.4, and why wouldn't I want to round down using my rounding rules? Then I won't have enough fencing. So I can't buy 0.4 of fencing. I don't want to round this down to 75, then I don't have enough. So your final answer is that you need 76 feet of fencing. Measure twice, cut once, right? No? Okay. Alright. Arc length. So there's two things that you can measure about an arc. It's measurement and then the length of it. Here's circle E, and those are all supposed to be radii. Let's say that this guy is 92 degrees and this one is 70 degrees. This is a diameter AC, so what would this angle be? 110. Thanks. How about this guy, AB? 88, right? Alright. So if I wanted to know the measure of arc AB, just its measurement, that's the angle measure that corresponds with it. So what would be the measure of arc AB in my little picture? 88. If I wanted to know the measure of arc BCD, in my little picture up here, how would I find the measure of arc BCD? Yeah, I'd add the 2 because I got to go from B to C to D. So 90 plus 72 is 162. Okay, so measure corresponds with the angle measure of the central angle. You can also find arc length. That would be the distance between your endpoints. Like how long is the pizza crust that you're eating. To do that, you have a little formula here. It says the length of an arc is equal to its measurement over 360 times 2 pi r. What's 2 pi r represent about the circle? Its circumference. So we're trying to find some fractional part of our circumference. So if you did flip over, flip back. If you haven't flipped over, hopefully you're on number 5. If I want to find the length of arc ADB, how long it is, I have to take the measure of arc ADB over 360, and then take it times the circumference of the circle. Okay, so the measure is always the angle measure. What angle measure corresponds with arc ADB? Good. 210. You have a worksheet today, so you'll be able to write on it. If they tell you arc ADB, follow that around. ADB would go with this, major arc there. 150, and that guy have to add up to 360. So you need to subtract your 150 over it, and this arc measurement is going to be 210. So instead of the measure of arc ADB, we're going to put 210 over 360 times 2 pi r. And our radius for this circle is what? 18. This thing says to leave it in terms of pi. So for most of you, you should be able to do this without your calculator. You have really good math facts and you're good at simplifying. That's all we're doing. When you leave it in terms of pi, it's just simplifying that expression. If I start on my fraction, what happens to my zeros? They cancel out. So now I'm left with 21 over 36, which both can be reduced by 3. So that would make it 7 over 12. So we're actually trying to find 7/12 of the whole circumference, because that's how big this arc is. It's 7/12 of the whole circle. Times 2 times 18 gives me what? 36 pi. Good. If you need to, remember a whole number is a number over 1. So when I go to multiply these fractions, you're going to go straight across. So if I go straight across, 42, thanks. You get 252 pi over 12, and then you have to make sure it's completely reduced. Can I reduce 252 to 12? Yeah, for sure by 2. I can go by 12? Oh, then just write it down nicely. So then our area, or excuse me, our arc length would be 21 pi centimeters. Or you guys, you can actually simplify that even more and be less dependent on your calculator. When you multiply fractions, you can reduce top to bottom on the ones that are stacked and top to bottom this way. So if I wanted to reduce first, 12 goes into 12 once. How many times does 12 go into 36? 3. Now I have smaller numbers to multiply. 7 times 3 times pi is what? 21 pi. 1 times 1 is 1. I get the same answer. It's up to you how you do it. But when you do it in terms of pi, don't be so dependent on that calculator. You're just reducing and multiplying. Try the next one. Find the length of a semicircle with a radius of 1.3 meters, and leave this one in terms of pi. Arc length is some fractional part of my circumference. A semicircle is what fractional part of my circle? Half. Of means to multiply, so when you find the arc length, you're taking some fraction times the circle's total circumference. Well, circumference is 2 pi times the radius, which they give us to be 1.3. What's half of 2? And 1 times pi times 1.3 is 1.3 pi. If you use your formula, a semicircle has a degree of what? 180. So you would have done 180 over 360 times 2 pi 1.3. But doesn't 180 just become 1/2? Yeah. So if you know what the fractional part is, you can start there and simplify it right away. Try the last one. It's only half of a circle. 2.6 would be the whole circumference, but I wanted a semicircle, so I just wanted half of it. 1.3 pi. Trace around that arc that you're trying to find the length of, so you know that you have the correct angle measure that corresponds with it. Arc ACB there is a measure of 140, so we're going to do 140 over 360 times 2 pi times 4, that's our radius. So there's your starting work. Okay, a lot of this is simplifying and multiplying. In your fraction, your zeros will cancel, so I get 14 over 36. Go down by 2, so that would be 7/18. So that's how much of the circumference we're trying to figure out. Times 8 pi. You need to put that over 1. I like to reduce first, then I don't really have so much thinking to do. 8 and 18 are both divisible by 2. And then I can't reduce anything else top to bottom, so now when I go straight across, 7 times 4 times pi is 28 pi. 9 times 1 would be 9. So 28 pi sometimes you'll see it written like this, 28.9 then pi, that means the same thing. The pi is on the outside or on the top. But this would be your arc length, or arc ACB. If this arc in blue is 7/18 of my whole circle, what would be the BA, the one in black? 11/18, right? Because don't they have to add up to 18/18 to make a whole circle? Okay. What would be the measure of arc AB? Not its length, its measurement. 220. Good. You would take 360 minus 140. Measurement is angle measure. Length is when you use your formula. Questions on circles?